Ah, all right. Let me just start my time. All right. Thank you, everybody, for joining again. I promise I'm the last one speaking about Amsterdam. So we're gonna keep in the loop of the same project, but I'm gonna focus more on the logistics and a spatial planning and a spatial picture of the city for Amsterdam Pavements. So quick introduction. It's all about a circular economy. I think there is not much to introduce here, but the biggest ambition of the Netherlands is to close the loop, so to reduce the use of the virgin materials and to use the existing ones for the sustainable, but also potentially for the financial goals. But in order to be able to deliver all of these materials in different nodes, we need to extensively use the logistics, and in this case, at the city logistics, which can cause problems. And in this study, we focus on the elemental verharding, which is a complex Dutch word for the pavements that we all speak about. So in Amsterdam, in the Netherlands, these little cobblestones and the bricks are very, very usual to see. And that's why these are the object of the study. So we go to Amsterdam, the North Holland, the Netherlands, and here is a quick map showing different pavement types in the city. So asphalt is present on like the main streets, but the paving, the modular paving elements are usually in all the side streets, in the pedestrian paths, in the cycling paths, in the main squares and so on. So they are overall present. So we focus on these three types. So concrete tiles, the first one, the concrete bricks, and the bricks in the study. And why we do it, I think already Ruben and Felix both explained. They are representing a part of the 1.5% of the Dutch CO2 emissions. But they're also, on the other side, very fitting for reuse because they're modular. You can take them out, you can store them, you can bring them to the new project. And for example, the clay bricks, they have a long life. So it would be just pity to demolish them or to recycle them. The best option for it is to reuse them. Also, Amsterdam has this ambition to become fully circular city. It's a very tough ambition by 2050, but the city, together with the researchers, is working on that. And I think the last reason why we do it is that in this case, compared to, for example, other construction materials, we have a big advantage of planning such things with the pavements because the roads are controlled by the municipalities. So we can really control the procurement process and quickly start the reuse. What's happening in the city? So Ruben already spoke about the hubs. One of these hubs is benches. You can see here in the images. They're using taking all the bricks, cleaning them and stacking up and making them ready for the reuse. And this is me and my colleague Felix on the field trip. This is a large city hub in Amsterdam where they store different furniture in the city, different materials, but also bricks, and they're making them ready for the reuse on the renovation projects in the city. So a bit back, this was a bit of an introduction of the problem, but coming back to science, the research problem here is that cities really want to become fully circular, and there is this ambition in the last 5-10 years, but they lack understanding what does it mean for the logistics, what does it mean for the hubs organization, and what also does it mean for the impact on the city, on the residents, on the neighborhood, what about the air pollution, what about the road congestions, what about different problems that happen because of this economical change. So there is also limited research on the logistical flows in a city, on a city level. So usually the researchers focus on the infrastructure project itself or the buildings. The policy is focused on circularity, but they don't understand it very well. And also there is no much findings about the impacts on the city and also about the social, spatial inequalities between the parts of the city that I particularly like to research. So our questions are in this work about tracking the next 5-year cycles of the road maintenance projects in the city. And we want to see how are they managed, operated, what are the potential impacts, what are the potential bottlenecks of the transport flows in the city in this 5-year period. But also further on, I would like to optimize these flows and see whether we can plan it better to reduce the CO2, the transport emissions, but maybe also on the other side to reduce the local negative environmental impacts, for example, safety or air pollution due to traffic flows of the trucks. So about the methods, we are first looking into the city and trying to understand the whole process. So there are certain components in this. There are certain components here. We have the projects. We have the production. So these are the places that are where the new materials are being produced, the factories, for example. Then we have the reuse in the city hubs already presented by Ruben previously, where the materials are going to being stacked and ready for the reuse. And then there are the recycling spots, or so we call them end-of-life facilities. So that's where the materials go at the end of the process. Also, we make the outgoing flows of the materials, we separate them in the three groups. So outgoing materials are the ones coming out of the project, and they either can be downcycled or recycled. So this is this end of the life goal, which we don't really want to achieve. We want to achieve as much as possible of the direct reuse. That means on a single project, you can take out the bricks and tiles and then eventually return them to the same project after the renovation is done. Or the indirect reuse means send them to the hub and wait for a certain amount of time and then bring them either to the same project or to another project in the city and keep the loop closed. So I tried to graphically present this in this schematic format to show what is going on in the city. And as I said, for example, we have the production of the new materials that would go to the project, while the old materials will go to certain hubs. And then from these hubs, the materials would eventually come back to the project. And in the last case, they would be recycled and sent to the end-of-life facilities. So our idea in this work is like to model it, to try to quantify what's happening in the city, to try first to understand it. So for that, we use the deterministic modeling. We use Python. We have given input and we try to take the output out of that. But first, we need to understand the process. So I'll explain a bit about that. Then the second, we collect different data sets. We did a lot of interviews with the private companies. We have data that Felix presented about the municipality. We have a lot of traffic data about the vehicles used and so on. And then we try to model that all together. So a bit about the modeling outputs. So what we got out of our work is, as an input, we gave this 315 project. This is the plan of Amsterdam for the next 5 years of the pavement project to renovate in the city. So that was our input. We knew the material quantities planned. And we made 3 scenarios. The linear, where is no reuse. Then we made the baseline scenario. This is the current reuse, which is not so high, around 40%. And we made a theoretically maximal circular reuse, which is around 85% of the reuse. So we made these 3 scenarios. We let the model run, and then we get such outputs. These are the material flows for the next 5 years, so we can see which projects are involved, which hubs, where the most of the flows around the highways of the city, around the hubs, and so on. And then we can also make different types of the flows. So the new material flows, the reused flows, and then end-of-life, the processing flow, so we can really see what is spatially happening in the city. I'm just going to quickly go through some outputs. So, for example, we can see that in this baseline scenario, the most new materials, are making the most kilometers because usually these factories are far away from Amsterdam. But it's a bit funny and interesting that they make the least trips. So the most trips are made by the reuse materials in the city because we have so many nodes and short trips from the hub to the project, from the project to the hub, and then eventually to the end-of-life facilities. Then also based on that, we can track amount of tons and the materials which can be used to advise the city for the hub capacities, for example, in the future. And then as an output, we have this transport emission. This vary based on the amount of transport, amount of the vehicles using the kilometers. And then it would be interesting here to add the electric vehicles to see how addition of electric vehicles would impact the CO2 and NOx emissions in the future. So I also compared these. So we used the linear. So there's only new and the old the new flows and end of life flows. But then in the baseline, these reuse flows come into the play. And then in the circular, for example, comparing the blue line, you can see that it's getting thinner and thinner. It more like new materials already are almost not anymore delivered to the city. And then to compare a bit of the KPIs, we see that the linear scenario is just making the highest amount of transport kilometers and correlated to that, the highest amount of the ton kilometers with the most weight transported. But interestingly, again, the circular scenario is making most trips in the city because of so many nodes that it has to connect. And then I concluded that the circular, based on all the parameters and outputs, saves transport emissions, so 3 times lower transport emissions than the linear. However, most of these transport is in the city, and that may cause a big problem for the city itself. As we said before from one research, maybe it's good for the world, for the global emissions, but not so good for its inhabitants and for the city. So that may be a downside of it. And just quickly about the discussion. So this kind of modeling is interesting because we can use different sensitivity analysis and really see what vehicle types or amount of recycled materials, how do they impact the overall emissions and the transport and the amount of trips. And also, this is still ongoing work. I want to work more on the impact of the logistics, potentially the negative impact on the logistics on the city based on it, and see really what does circular mean for these neighborhoods and for the people living around certain hotspots like the one here where the circular hub is. Takeaways, I think the circular is promising, but we have various trade-offs, as I kind of said, the potential negative impacts. Also, the city needs to have such models to make more hubs and more storage facilities. And we also need to think not only circular, but based on this, we need really to think holistically about the whole systems. And some of the limitations is always with the models, they're not always representing the real world. There are a lot of assumptions, a lot of parameterization, and a lot of simplification. For example, we didn't include any costs in this analysis. And to be really applied so that we can make a change, we really need to work with the policymakers, with the urban practitioners to see how to start using these models in the practice. So this is a bit of a bottleneck currently that we want to tackle. Yes, I think that all circular logistics. Thank you very much. All right.
Thank you very much for that presentation.
Yeah.
So there must be some segregation based on the material type. That is my question. Second, if you please